what tool to use? Algorithm. What trig should I use? So I look at a triangle and say, is it a right triangle? Question mark. I can make a flow chart, but I don't feel like it. Is it a right triangle?
And if it doesn't look right.
Yes. If it's a right triangle, what do I do?
SOHCAHTOA.
SOHCAHTOA. SOHCAHTOA. If it is not a right triangle, if it's not, then we'll go down to number 2 and say, do I have opposite stuff? Right, because that would be the law of sines, right? When you have opposite stuff. Do I have opposite stuff where I have an angle here and a side here and then the angle here and the side here? You know what I'm talking about?
Yes.
Yeah.
Yes? Okay, do I have opposite stuff? If yes,
Law of sines.
law of sines. Right, and I think Zoe asked the question, hey, what if we don't have opposite stuff? What if I don't know angle A or side A?
You gotta find it.
OMG, what should I do? We're going to use the law of cosines. Right, so if I can't do this and I can't do this, surely the law of cosines will work.
Really? Is there no other option after that?
Well, there's always more math, bro. But this is the main get down on trigonometry. These are the 3 major tools. So, what is the law of cosines? You may be asking yourself.
No, not
Well, I'm here to tell you.
I was asking myself.
How did you know? Okay, so no, that would be nice. That would be very nice. It wouldn't be a different tool though, because we would still need opposite stuff to solve that. So, law of cosines. Law of cosines. You guys remember that thing? I'm going to write it this way for funsies, but a squared plus b squared equals c squared. Remember that guy?
Yes.
Yeah, I remember from earlier today.
So, Pythagorean theorem is actually a special case of the law of cosines. So, in general, for any triangle, c squared equals a squared plus b squared minus 2ab cosine of c. And so this thing right here, does anyone happen to know if it's a 90-degree angle? Does anyone know the cosine of 90 degrees?
Is it 1?
You can type it in your calculator.
That is 0.
One.
Oh, it's 0.
I don't
Lisa,
remember.
what did you do to make
It's
it?
the
one.
circle of
It is
whatever.
1.
It's one.
It's
And
zero.
then
Point.
It's zero.
cosine of 90-degree mode, not radian mode.
Oh, wait.
Cosine of 90 degrees is 0, so when it's a 90-degree triangle, this is 0 times who cares? This is all 0.
Or so it doesn't.
So when it's 90 degrees, this vanishes, and Pythagoras was correct after all.
Oh, so it's a special case with the right triangle.
Zoe and Carson, are you okay there? I'm worried about your life. Okay, if you need to move, there are many open seats that are, because you're facing not me, you know what I mean? So if you were to sit, there are seats that face me. If you find that to be helpful for you, feel free to move about the cabin.
Definitely not.
Okay. So here's the deal. It's like Pythagorean theorem, but you subtract 2 times these things times the cosine of that angle. Yeah, and so let's say I want to solve a side. I need to have the other 2 sides and the angle between them, right? Because angle C is going to be in between side A and side B, believe it or not. So this describes a side angle side condition, right? Let's prove. Right, we have A, B, C. This is little a, little b, little c. So if I have little a, little b, and little c, if I know those three facts, side, angle, side, I can solve the opposite side. So law of cosines is sweet if you have side, angle, side happening. Or if I knew all three of these sides and was missing an angle, I could find an angle. So if I had side, 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 that would work also, because I can plug in for three things and solve for the fourth. Eh? So side, angle, side, or side, 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 that works out fine and dandy. So so here's the thing. I want to get rid of this c squared riffraff. Let's do this. That way we're solving for a side length, which is c. Yeah, so c is equal to the square root of a squared plus b squared minus 2ab cosine of big C. Now what if I wanted to solve for side b? That would be the square root of, what are the other two sides?
A squared
Plus c squared minus
2AC.
2ac times the cosine of b, of big B. And then if I wanted to solve for little side a, it would be
B squared
cosine of a. Right, so this is a arrangement. I mean, this is the law of cosines for any, side that you have. But if you don't have them labeled, because you don't have to have them labeled A, B, C, you can just have, let's say you have a triangle where this is 13 feet and this is 20 feet and this angle here is 80 degrees. If you have a side angle side, you could solve for this missing side here. And so all we do, if you want to label all the A's and B's and C's because that helps you keep your life in order, go for it. Or you can just say this missing side is going to be the square root of the other two sides, right? So it doesn't matter which one. Let's do 13 squared plus 20 squared minus 2 times 13 times 20,
Just put 260.
or that, and then
Cosine of 80.
cosine of 80 degrees. Right, it's not that bad. It looks kind of scary. You're like, there's so many
On the page, are
formulas.
you gonna put that there because that's a lot to remember?
Yeah, well, you'll use it for a little while, and then after a while, you'll be like, oh, I got this. I promise you, it's a weird thing. It's Pythagorean theorem minus another little thing. But this it's minus 2, this times this, cosine of that. Right, you use it a couple times, and you're like, oh, I got this. Bang, bang. But yeah, probably if we do a big trig test, I might have these available for you. Whatever. Not a big deal. Anyway. No, we don't need a test? Okay. I appreciate that. That's big of you.
Yeah, no problem.
So side angle side. What about if it's side, side, side?
Well, then you just have a variable.
So we could plug it in here and then solve it, or we could just solve it in general algebraically and just come up with a formula that works. So we could come up with 3 more formulas for big C, big B, big A. We could do that. So let's do that, because then if you just do the algebra one time in the general form, then you never have to do it ever again. You just plug it in. So
I think it's annoying that uppercase C and lowercase c look exactly the same except for size.
yeah.
Put a little thing on the top.
Yeah, man, I can do like a little C. Well, it's got a little calic. I don't know. Whatever. So if I had, let's do c squared equals a squared plus b squared minus 2ab cosine of big C. Well, C. Well, fella. Let's rearrange this to solve for big C. Let's solve for the angle. So if I'm going to solve for the angle, I should subtract these two off, right? Minus a squared and minus b squared.
Don't you just divide both sides by C? And then multiply something?
Those are two different C's.
I know.
Huh? No, so we want to get big C by itself. That means we need to get rid of all the other stuff.
Okay.
Yeah? So let's move some furniture. So now we're going to have
C squared minus A squared.
C squared minus A squared minus B squared equals negative 2AB
Cosine.
cosine big C. I need to get rid of this stuff. What do you think?
Even a negative
Divide by
cosine?
2AB. Negative 2AB.
Divide by negative 2AB. So all that divided by negative 2AB.
And then you cosine to the negative 1.
You fix your mouth.
Inverse cosine.
We're going to inverse cosine, right? Because we got to get rid of that cosine to get angle C. So we better do the opposite of cosine, which is what, Dylan?
Inverse cosine?
Yes! Okay. So we're going to
Why
do
can't we just say cosine to the negative 1?
because then you get stabbed. So inverse cosine. Did I say that out loud?
Was that a threat?
No. That happens sometimes.
You know what?
I wouldn't want that to happen.
Of course.
Right, then, yeah.
I want you to fall on a knife.
It's not a threat.
Okay. So the cosine and the inverse cosine kill each other. This is getting scary. Okay, so now we have the angle C. I'm gonna flip flop it. So big C is equal to the inverse cosine of little c squared minus a squared minus b squared, all divided by negative 2ab. Woo! There's your formula. Go tell that on the mountaintop.
No thanks.
I'm going to erase all this
Let's define an angle.
jambalaya. And then let's see if you see the pattern. So how about angle big A is going to be what? Someone's got the formula. Cosine.
A equals
Inverse.
Cosine to the
cosine
negative 1.
Inverse
negative 1.
cosine.
Hang on, one person. Let me get one person. Dylan.
It'd be an a squared, little a squared, minus little c squared, minus b squared, over negative 2 cb. And then in parentheses.
And now, just because it's freaking me out a little bit, by convention, we generally list our variables in alphabetical order. So we would put, it doesn't matter, this is totally correct, but I'm getting a little OCD right now. So I'm going to put B and C. You're totally right, Dylan. Let me be weird, okay? Not that I really need permission for that, but. And so the other one, Zoe, you got me?
Yeah, E equals the cosine inverse of A squared minus, B squared minus A squared minus C squared over to AC.
Negative 2 AC. Yeah?
Yeah.
Woo!
That's
Alphabetical order would just be negative A squared plus B squared minus C.
Well, so the angle that you have is going to be the first side, and that has to be positive. The other ones are negative. Bless you.
I thought you were gonna
So big B starts with little b squared and negative other stuff.
Yeah.
And it's an alphabetical
Big C
order.
is little c squared minus the other stuff. So, for example, let's say we had a triangle where this is 9 centimeters, and this is 11 centimeters, and this is 14 centimeters. You think that could be a real triangle? Think about you have 11 and 14. You could probably do this with them until it made 9.
Yes. Yeah, you can do that.
Okay, so it's real. Yeah, I don't know what the angles are, but we can find them. So let's find this angle here. We can call it big A if you want to. So if I'm going to solve for big A, it's going to be an inverse cosine of what is little a?
Little a.
14 squared.
So 14 squared minus the other stuff squared. So minus 9 squared minus 11 squared. You guys following me?
Yeah.
Yes.
Yeah, you okay, Weez?
Over
-2.
Over 2. -2 times
11 to 9. Or 9 and 11.
Times these two same things.
Oh, jeez.
And so a lot of people are going to end up getting errors in their calculators for a lot of different reasons. One is because, now this is super important because you can think you're all smart and correct, but if you can't press a button correctly, you're going to fail. So this whole top needs to be bagged. You need to bag your numerator.
Bag down.
Otherwise, it's 11 squared. And
Yeah, otherwise it's just 11 squared divided by stuff. Instead of the whole top divided by stuff. So double bag your groceries. And then down here, this is not a minus sign. This is a negative sign. Know the difference. Yeah?
Okay.
Because people will put a minus sign here and get a syntax error and they go, my computer is dumb, it's not working. My calculator's broken.
garbage in, garbage.
So double bag your denominator. And watch out for, these are minuses, that's a negative. That means inverse. Try it and see what happens.
If you type in cosine and then exponent 1, exponent -1 will be the same thing.
No. You'll probably get a reciprocal.
Oh.
Yeah. Alright. So try that and see what happens.
Oh, I got it. 88.26.
Yes.
So 88.3 degrees.
And then we
Let's
can,
just say 88
I got
degrees.
88.
and then we can sign the rest, right? Now that we have opposite.
You could, but let's ride this.
You can do that.
Let's ride this till the wheels fall off. So let's go. Somebody else. Front row, Megan.
I'm having trouble with my calculator.
Oh.
Which is our point?
We'll make this B.
Can I have a little of that?
Big B. Big B.
Wait, 9 squared.
Are you ready to get in the game, or do you need a moment? Okay. Okay. Who do I need?
I got 80.
Drake.
I got you. Look.
You know,
Okay,
you put a negative
So big B equals inverse cosine 9 squared, right? Because that's going to be the side
Okay.
opposite B. Minus 11 squared minus 14 squared over -2, 11, 14.
You guys see the pattern? You see how it fits in here? Type all that in smooth and see what you get.
39.9.
Wow,
That was
that's
fast.
great.
That was like 2 seconds ago.
Or less.
Yeah.
39.9, so 40 degrees?
Yeah.
We round to 40 degrees?
No.
And I know these need to add up to 180 and you can subtract them and stuff, but let's see if this newfangled technology works. Let's try to plug it in this thing.
Yeah, we're testing.
So front row Megan is ready for the Super Bowl.
I got error.
I got an error.
Okay. So the inverse cosine parentheses. Oh, yeah, I guess I'll get back later. C. So you're going to need 11 squared minus 9 squared minus 14 squared over -2 multiplied by 9 and 15.
So you can totally understand it. Don't just watch me do it and then people shout out the answer and not try it for yourself. Because The hardest part is typing this into your calculator and not getting a syntax error or a domain error.
That was pretty easy.
Both of which mean either syntax error means you messed up a Ron. A domain error means either you messed up or it's not a real triangle. It depends. Could be user error. You doing okay typing that in?
Brain air.
You're good? What are people getting for that?
You got an error on
51.7.
Oh, I got 20.53.
Whoa. You got 52?
52.
Yeah, 52.
51.
I think 52.
Oh, wait, I divided it wrong.
Oh my gosh, wait, did I get the same answer? Wait, Ika, what did you get? 52. 51.7.
Yeah. Oh my gosh, do those add up to 180?
Yeah.
But the number works.
Yes.
That makes it $1.40 and 40.
I got it.
Preach! Hallelujah!
Bro, I can't.
I don't know what that means. It means mine.
Wait, what does the domain error mean?
Domain error means either. So here's the thing.
Yeah, I missed that.
Let me give you a little sneak preview about inverse cosine and sine stuff. The cosine. Okay. Let me erase a thing. So you guys remember that the cosine is the adjacent over the hypotenuse, right? So the cosine of an angle, adjacent over hypotenuse. The hypotenuse is always the longest side, right?
Yeah.
This is always bigger than that, right?
Oh, so
Except when this collapses, you have a 0 degree angle, then the hypotenuse is the adjacent, and you have hypotenuse divided by hypotenuse is 1. So the maximum that the cosine can ever be is 1. So if you type in a bunch of stuff in here that turns out to be bigger than 1, and you try to do the inverse cosine of that, it's the calculator's going to go, what are you talking about? Right? Because the cosine can only ever give you something up to 1. It can give you a fraction. Basically, the cosine lives
Between 0 and 1.
It actually lives in between 1 and -1, but don't let that scare you. But it lives in that little range there.
I bet it's bigger than my house.
So if you forget a parenthesis and you got a 14 squared running wild in there,
it's going to get cray-cray.
yeah, and you're going to try to take the inverse cosine of like 500 or something,
Your calculator's going to be like...
it's just going to explode, blow your arm off. Ah!